Well, turns out we can do something similar in general, no matter what these values of a, b, and c are. We'll just try to first complete things to a square. Okay, so let's do that. So, in general, well, let's maybe slightly less general, and let me assume that a is non-zero. Because otherwise, I can't do what I'm going to do. So I'm going to write this as a times x squared plus b over a xy. Then I have my cy squared. And now, this looks like the beginning of the square of something. Okay, just like what we did over there. So, what is it the square of? Well, you'd start with x plus, I claim if I put b over 2a times y, and I square, then see the term, the cross term, 2 times x times b over 2ay will become b over a xy. Of course, now I also get some y squares out of this. How many y squares do I get? Well, I get b squared over 4a squared times a, so I get b squared over 4a y squared. So, and I want, in fact, c times y squared. So the number of y squared that I should add is c minus b squared over 4a. Okay, let's see that again. If I expand this thing, I will get ax squared plus a times b over 2a times 2xy. That's going to be my bxy. But I also get b squared over 4a squared y squared times a. That's b squared over 4a y squared. And that cancels out with this guy here. And then I will be left with cy squared. Okay, do you see it? Kind of? Okay. If not, well, try expanding this square again. Okay, maybe I'll do it just to convince you. But so if I expand this, I will get a times. Let me put that in a different color because you shouldn't write that down. It's just to convince you again. So if you don't see it yet, let's expand this thing. We'll get a times x squared plus a times 2x b over 2ay. Well, the two a's cancel out. We get bxy plus a times the square of that. That's going to be b squared over 4a squared y squared plus cy squared minus b squared over 4a y squared. Here the a and the a simplifies, and now these two terms simplify and give me just cy squared in the end. Okay, and that's kind of unreadable after I've cancelled everything, but if you follow it, you see that basically I've just rewritten my initial function. Okay, is that kind of okay? I mean, otherwise there's just no substitute to, you'll have to do it yourself, I'm afraid. Okay, so let me continue to play with this. So I'm just going to put this in a slightly different form, just to clear the denominators. Okay, so I will instead write this as 1 over 4a times a big thing. So I'm going to just put 4a squared times x plus b over 2a y squared. Okay, so far I have the same thing as here. Okay, I just introduced a 4a that cancels out. Plus, for the other one, I'm just clearing the denominator. I end up with 4ac minus b squared y squared. Okay, so that's a lot of terms. But what does it look like? Well, it looks like, so we have some constant factors, and here we have a square, and here we have a squared. a square. So basically, we've written this as a sum of two squares. Well, a sum or a difference of two squares. And maybe that's what we need to figure out to know what kind of point it is. Because see, if you take a sum of two squares, then you'll know that each square takes non-negative values, and you'll have the total, the function will always take non-negative values. So the origin will be a minimum. While if you have a difference of two squares, then typically you'll have a saddle point, because depending on whether one or the other is larger, you'll have a positive or a negative quantity. Okay, so I claim there's various cases to look at. So let's see. So in fact, I claim there will be three cases, and that's good news for us because, after all, we want to distinguish between three possibilities. So let's first do away with the most complicated one. What if 4ac minus b squared is negative? Well, if it's negative, then it means what I have between the brackets is, so the first guy is obviously a positive quantity, while the second one will be something negative times y squared, so it will be a negative quantity. Okay, so one term is positive, the other is negative. That tells us we actually have a saddle point. We have, in fact, written our function as a difference of two squares. Okay, is that convincing? So if you want, what I could do is actually I could change my coordinates, have new coordinates called, I don't know, u equals x plus b over 2ay, and v, actually, well, I could keep y, and then it would look like a difference of squares directly. Okay, so that's the first case. The second case is where 4ac minus b squared equals 0. Well, what happens if that's 0, then it means that this term over there goes away. So what we have is just one square. Okay? So what that means is actually that our function depends only on one direction of things. In the other direction, it's going to actually be degenerate. So, for example, forget all the clutter in there. Say I give you just the function of two variables, w equals just x squared. So that means it doesn't depend on y at all. And if I try to plot the graph, it will look, well, so x is here. So it will depend on x in that way, but it doesn't depend on y at all. So what the graph looks like is something like that.